Hey, and welcome to Need to Make It. This is the brand new QIDI Q1 Pro, and this printer is so solid that it can print just as well like this, as it can sitting on my workbench. This printer is also loaded with features that you normally see on an expensive printer, and also one feature that you would not even see on expensive printers, but this printer is far more affordable. So in this video, we're going to see what makes this printer different, and we're also going to see just how well this printer performs on some of the toughest materials to print with. So stick around. This channel is growing quickly, and every bit of support helps me to provide even better content and more content as well. So consider subscribing if you haven't already, because the goal is to get to 100,000 subscribers or more by 2025. And of course, those likes and comments are always appreciated as well and help with that YouTube algorithm. So let's get into it. This is the first time I've tested one of QIDI's printers, and this was sent to me from them to test out. Now, before we get printing, I wanted to cover some of the most important features of this printer. We have a very big, thick steel frame, and that means that this printer is extremely stiff. It's also wrapped with this ABS cover, and that is important for one of the other features that this printer has, but we're going to talk about that one a little bit later on. There is an integrated touchscreen, and that just helps to keep everything nice and clean. We also have a polycarbonate top and a polycarbonate door, and they're both clear, which means that it's easier to see inside of this printer. The door opens beyond 180 degrees, and there is a big, thick, large hinge. The top also can be removed completely, really easily, but if you want to have a little bit of airflow, you can position it just like this and open it just a crack. On the inside, you can see the steel frame. It's also corrugated. We also have both the small pulleys, which is great for reducing VFAs, and the motors are offset by a fair distance, and that allows them to space the belts out here further, and it has these blocks centrally mounted on the Y-axis rail, and that just makes everything a little bit more stable. And while we're looking at this, these are all super thick, beefy, glass reinforced parts. At the back, we have this automatic nozzle wiping system. This is one I haven't seen before. This has a felt pad, which is replaceable. It's also spring-loaded, so it can keep the right pressure on the bottom of the nozzle. And there's a purge bucket below that as well. The cool thing about this system is that this nozzle wiper works both in the X-axis and in the Y-axis, and it cleans both directions on that nozzle and not just one. It's probably a little bit difficult to see up in the corner there, but there is a spool tangle sensor. And here we have a nice gradual feed for the PTFE tubing into the extruder. This printer also comes with this webcam, and this one's kind of neat because you can reposition it easily with these little knobs. For raising and lowering the Z, we have 2 lead screws, and the bed system rides on these rods. And there's fairly large linear bearings underneath. Each of these is driven by its own motor. So this cover comes off really easily, which is nice. So we see a glass reinforced extruder assembly, and there's also a filament runout sensor right here before the extruder. This printer has a copper heatsink. And we're also seeing a large extruder gears, and that reminds me a little bit of the Bondtech LGX. Let's see what's under this cover. So here we have an inductive probe, and on the back side, you can't see it, but there is a ceramic heater. And this particular heater and this nozzle can get up to 350 degrees Celsius, and that just makes printing higher temperature materials a little bit easier. This nozzle is not exactly like a volcano style nozzle. This one is a little bit shorter, and it's also bimetal, which means that we can print abrasive materials right away. a little bit difficult to see, but there are 3 points of connection from the heater or the heater core to the heatsink assembly. And that just makes for a little bit stronger connection. I just noticed that there are these little magnets here built in as well, both on the head and then on the inside of the cover as well. I want to take this apart just a little bit and have a look inside. So all of the electronics are at the back, which is really nice to see, out of the way of any heat. If we pull this off, oh, look at that. Geez, I haven't seen this before. This is a helical gear. So here we have the helical gear driven by the motor. And behind that, and hopefully I don't lose any bearings, it's a very tiny bearing. And behind that we have a steel spur gear. And this one is also set on a spring as well to always keep pressure on the filament. It's a simple setup. That's pretty nice. I think it's time to get some prints going on this new printer. So we'll start with something simple and then work our way up to something that's fairly complicated. And QIDI does have their own slicer. I'm going to be using Orca Slicer in this case, and it's not very difficult to get set up on this printer with Orca Slicer. And this printer has a fluid interface built into it for the UI, so we'll be using that within our slicer. So first off, let's try a material that looks amazing, and that is PLA carbon fiber. It's not really that hard to print with, except that it is abrasive, so the bimetal nozzle is going to be required for this print. All of these prints are also going to be heavy duty, and what I mean by that is that they have lots of walls, tops, and bottoms, and they have dense infill. And parts like this are usually hard to get good results on because it normally requires you to have all of your filament settings dialed in perfectly. That said, I would like to test this printer under real-world conditions, so I'm just using the stock settings for each filament, and if I can produce good results here, it can be even better with the filaments calibrated. So these are some handles that I designed for a wardrobe cabinet that I'm restoring. Well, I have to say, for my first prints on this printer, these look really good. And I actually need these, so I'm going to tap these holes and get these mounted. These are the replacement for this. And these handles turned out super clean and professional looking. They don't even look like 3D printed parts unless you're really, really close to them, which is exactly what I was looking for. I don't have much experience with printing TPU, but let's throw some onto this printer anyway and just hope for the best. These are some replacement pads that I designed for my small quick grip clamps. These are going to be made from ordinary TPU. It's not the high flow stuff, so it is going to be a slow print. But these are looking really nice, and they were printed with 8 walls and 45% gyroid infill, which is going to be really close to a solid part. And they should be pretty stiff, which is exactly what I'm looking for. All right, this is pretty cool. So I have had these clamps since I was just a teenager. So they have served me well, but they've taken some damage. So I have these replacements that fit on just perfectly. Beautiful. Now, one other thing that I did, I printed these stilt versions, these taller versions, and the reason for this is because for my tools in my shop, a lot of them are cast iron, and when I want to clamp to cast iron, it's hollow underneath, and you can never reach underneath there with one of these clamps. So now I have the stilt version, and I'll be able to reach underneath. And I've also added a slight, you can see there's a slight angle on each of these sides because when you clamp this down, the pressure that's applied bends these two faces apart, but now with the angle, they're still parallel. So just overall, a better clamp. This is going to be really useful. I just wish I had yellow, but that can always be addressed later on. I'm also restoring a Tamiya RC car, and I needed a replacement bumper. And I was also missing one of the brackets, so to keep the bumper in place, I designed these, and they are printed from just basic PETG. All the TPU prints came out really clean. My only complaint is the white color, and there was some extremely fine stringing, and I think that is a pretty common problem with TPU. My first attempt for the bumper turned out great, except it's way too stiff. There's just not enough give. So I went ahead and reprinted it in this version, and that is so much better. That's just perfect. Let's go ahead and get this mounted. I also did a PETG version, which has a small amount of give, but not nearly enough. So now let's move on to some even tougher materials. So I have this brick red. Let's take a look and see how this one turned out. So I'm using the beta version, the new version of Orca Slicer, and I've activated some of the new features, and I think I made a bit of a mistake with some of the new features. I really should have tried it out before I did this, but regardless, let's have a look at how this turned out. I noticed when it was getting near the end of the print that on the nozzle there was a bit of a blob forming, just like what I would have on the X1C. Oh yeah, you can see there on the back, I've got some problems going on. Overall, it looks pretty good, but there is a little bit of trouble going on, and I don't know whether that's because of the holes. It looks as though just beyond each of the tops of the holes I'm having this trouble. Probably a different way that I can create these holes in order to avoid that. That's super stiff. The original one that I printed is not quite as stiff, pretty close. This was printed on the bamboo, and you can see I had, again, some cooling issues. I didn't have as much trouble. Well, I guess I did actually have a little bit of trouble around some of the holes. I didn't realize that it was black, so it was hard to see. It looks pretty good. I'm not unhappy with this. I think I need to go back to the original settings that I had in Orca Slicer, not activating the brand new settings because obviously I don't know how to use them, and maybe just a little bit more cooling, and this should be good. I'm going to go ahead and reprint the back piece as well, because this one is from just basic PETG, not carbon fiber, and it's a little bit too flexible in my opinion. So I'm going to go ahead and reprint this one. So the first couple of parts that I ran look amazing in the areas without bridging and overhangs. And I just need to either add a lot more support or adjust the design. The part quality is incredible, and these parts are really stiff, but the overhangs and the bridges suffer. Next up, let's move on to one of the most common filaments, yet the hardest filaments to keep flat, and that would be ABS. And unless you have very small parts, ABS requires an enclosure, and even better than that would be a heated build chamber. And it just so happens that this printer has both of those. Normally, when I print heavy ABS parts, they want to warp, and if the build plate bond is good enough, they'll pull up a little bit on the build plate and pull it away from the magnet. And those parts will not end up perfectly flat, and the print quality will be slightly impacted by that. Now, if you're printing high temperature materials, typically you would want a filtration system, and this printer does not come with carbon filter. But this is a model that was provided to me by QIDI, and it's supposed to be printed from ABS or another high temperature material. So let's see how this one turns out, and I'm using mouse ears rather than the entire brim, because it should make it even more difficult if it wants to pull away from the build plate. We are going to set the chamber temperature for this to around 55 degrees Celsius, and since this printer has an ABS case, it is going to be a pretty good insulator as well. So we shouldn't lose as much heat as we would if it were aluminum. This part has a lot of extrusion and retraction cycles for the holes, so it should be a good test to see how precise the extrusion is. And this turned out pretty good. Those holes are nice and crisp, and it looks like it stayed flat, even though this is a completely solid part. But how flat is it though? It's pretty flat actually. There's probably about 0.25 millimeters of warpage, and at that level it's hard to know if that was because of the plastic warping or if it was transferred from any irregularities in the build plate. Well, unfortunately I don't have the correct pellets to put in here. I have these. These are for a resin printer, but for now I will just go ahead and put one of them in there just for good measure. And when I get the pellets, the proper pellets, I can fill this up. Let's get this mounted in the printer. And there we have it. Looks pretty good. It fits nicely. It's a little bit tough to get those tiny M3 screws in there, but we got the job done. Let's go ahead and print some more parts from ABS that I need and see how they turn out. And these all look really good. And again, these are all super heavy duty parts, 8 walls, 45% infill, and I have no complaints whatsoever with these parts. Now for the final test, I want to do a large polycarbonate print. And for this one, the bed temperature for polycarbonate is around 110 degrees Celsius. Nozzle temperature is 280. There's no doubt that this is a high temperature material. This is nearly a solid part as well, and I'm using cubic infill on this one. We're also going to set the heated build chamber on this print to 56 degrees Celsius, and I'm looking for this part to stay nice and flat. I'm printing this replacement plate, which is for the Ender 3 version 3 model KE, to replace this steel plate. So this is pretty large. It's about 200, well, it is 200 by 200. This print should also shrink by about 0.5 millimeter overall when it's cooled, so I have compensated for this in the slicer. This plate stayed nice and flat even though it's a big print, and it looks perfect. I'm going to mount this onto the printer and see if it works better than my original design. This is the original steel plate that came with the printer here. This is much too heavy. This is my prototype, and it is quite a bit lighter, but unfortunately there were some details that I just didn't think about. One of them is that past these supporting points here on the linear rail carriages, This was flexing a little bit too much because I hollowed those areas out. I've also left some webbing in this area, so this is a little bit heavier than my prototype, but still far lighter than the steel version. I've printed all of these parts from all of these different materials, and this printer was able to handle them easily. So are there any flaws with this printer? The power switch is a little bit hard to reach from the front because it's more centrally located at the back of the printer. From the front, but just barely. There is no auto calibration yet, and for a printer at this price point, I wouldn't really expect it to come with its stock, but I would like to see an option to add one on. And the same goes for multicolor or multi-material printing. I'd like to see an option for that one as well. The side-mounted spool holder likes to flex a little bit too much for my liking, and because it sits on an angle downward, the spool has the potential to come off if the conditions are right. Luckily, this is something that's really easy to fix, so it's not really a big concern. The inside of the top panel has some scuff marks on it from the reverse Bowden tube or from the feed tube rubbing up against it. The interesting thing is that it seems to only be the pattern from when I was running the polycarbonate. I'm not sure whether that's to do with how stiff that material was or not, but in any case, it'd be nice to have a little bit more clearance there. Even 1 or 2 more millimeters should be enough. And the positioning of the build plate is done with this one center piece back here, rather than one at each corner. And that just makes it a little bit more difficult to position the build plate correctly. Like I mentioned before, this printer does not come with a filtration system, but the carbon filter is printable on this very printer. I prefer to retract the filament to change it, but the process for loading in new filament that is on the touchscreen requires you to cut the existing filament. Both methods work. I just prefer to fully retract the existing one to get as much of it out as possible before loading in the new filament. These are all luckily small problems or even wants and not needs, so they've obviously done a really good job on focusing on the core requirements like the extruder, like the hot end, and like the structure to give us a printer that performs really well, but also keeps it in an affordable price range. So now I had some of the negatives. What are some of the good points about this printer? I have leveled the bed only once, and that was through the startup process or the walkthrough on this printer, and that is it. All of my prints have had nice first layers. I've had only one error message so far, which is because I set the chamber temperature at 60 degrees Celsius and the chamber temperature ended up going up to 61. So I'm going to stick to 59 or even less than that from now on, just to make sure that I have a little bit of a buffer. The only material that I had any trouble with was the PETG carbon fiber, and that was in the areas with severe overhangs and with bridging as well. Otherwise, those parts looked amazing. I was able to achieve really good results, and I didn't even calibrate the filaments. I just used the stock settings from those Bambu filaments. Parts that would normally warp are staying extremely flat, and I know I am still using glue stick no matter which filament, which probably does help a little bit. There is no need to root this printer. You can access everything right away. QIDI has its own slicer, but you can also just use Orca Slicer or your favorite slicer right away, which is exactly what I did. And if you want to use Orca Slicer, by the way, you can simply type in the printer's IP address and then :10088, and that should get you to the UI for this printer. QIDI has focused on enclosed printers since 2014, so it isn't really that big of a surprise that they know what it takes to make a good printer that works really well at a good price. The thing about this printer is that it is affordable with the ability to print materials that you'd normally only be able to print on one that is about 2 or even 3 times higher in price, because even the Bambu X1C doesn't have active chamber heating. And QIDI has also told me that there is an early bird price on these printers, which is going to be $130 US less than the regular price. And at this point, when I'm making the video, the regular price of the printer is $599 US and the early bird price is $469 US. And I will leave a link below if you want to check that one out. If you do use that link, this channel does get a small portion of any sale, so we can keep making content like this. Thank you to each of my patrons for helping to support this channel and making videos like this possible. And as always, if you want to help support this channel as well and make more content and better content, there is a link down there in the description below. Also, if you'd like to see more videos showing off what this printer can do, let me know down there in the comments. And I hope you found this video helpful. Take care, everybody. We will see you on the next one.